Gentlemen, good afternoon. I welcome you all to this afternoon session. I am Officer, Mechanical Department of this university. I am supposed to conduct this afternoon session. Anyway, I think it is better to talk of the number of papers. I see there are 8 papers here and we have 2 hours time. So for each paper, we have 15 minutes. So I request you to complete your presentation by 10 to 12 minutes so that rest 3 minutes or 5 minutes we can use this time for open discussion. Okay, according to this schedule, the first presenter is Onuk Shirkol and T. Nasser. Paper is hydroelastic analysis of floating platform under different support conditions using boundary element approach. I am not sure who is the author. There are 2 authors, Onuk Shirkol and T. Nasser. Is author still here? We will come back here again later. Second paper is a simplified method for analyzing the static life of a FPSO mooring system. Presenter is Muhammad Saidi Hassan. Okay, please come up here and let's start your presentation. Mr. Muhammad Saidi Hassan. Paper ID 68.
Bismillahirrahmanirrahim. Welcoming you all to my presentation for the topic a simplified method for analyzing the fatigue life of a FPSO mooring system. Actually, this FPSO is my research topic here, and I use the vessel for analyzing the mooring lines of the fatigue life of the mooring lines. Okay, before starting the presentation, I would like to introduce myself. I'm Muhammad Saidi Hassan, and I have actually graduated from. এটা ওই আলো রিফ্লেক্ট করতেছে মনে হচ্ছে অনেক। কন্ট্রাস্টে করে দেবো, ইয়ে করে চেঞ্জ করে দেবো, কিন্তু অনেকগুলোতে আছে। ঠিক আছে, আচ্ছা লাইটের জন্য হ্যাঁ এটা ইম্পর্টেন্ট না, কিন্তু পরে 2-1টা স্লাইডে বোধহয় একটু আছে, বাট আমি বলে দেবো, সমস্যা নেই বোধহয়। Okay, let's continue again. I have graduated from BRET in 2013 from Naval Architecture and Marine Engineering Department, and later I go to Norway for doing my masters. Now I'm working as a lecturer in Shonaga University in the Department of Naval Architecture and Marine Engineering. So let's come to the content of our today's paper topics. And it's first of all, we will discuss something about the background of the research work. Then we will talk a little bit about the PSO marine system to give some idea. And then we will discuss whatever methods we have already available for analyzing the fatigue analysis of the marine system. And then I will discuss my proposed method that we can use instead of those state-of-the-art methods. And later I will discuss how I have developed the model and also some resultant discussion. And in the end, we'll recommend some further work, what we can do. Okay, so whenever we're going to develop a new method, the first question comes into our mind is why. So the thing is that what method we already have in our hand, they are actually very time consuming. Because in the frequency domain and the time domain analysis, you need to have, in frequency domain it's not that time consuming, but the accuracy is not that much. In contrast, the time domain analysis is very much accurate, but the simulation needs a lot of time. So we are trying to propose a method that can give the same result as like the frequency time domain analysis, but it will take lesser time. So you can also see that in offshore, for some offshore structure like the FPSO and mobile offshore drilling units, like this MODU, mobile offshore drilling units, for this, because they are not operated in the same location always. They tend to travel from one place to another. So the fatigue analysis for those are not that much realistic due to the lot of time that required for the analysis. So I'm trying to propose a new method. If we use that method, it will not take that much time. So you can simply just use my method and just check the fatigue life of that structure. And if you see that it requires some detailed analysis, then you can just simply do the real-time analysis. So that's one part for my doing this research work. Okay, just to give you some idea what I am talking about. Here in the left corner, you can see the PSO that is connected with internal turrets. And in the middle, that is a disconnectable internal turret. That means the turret where all the mooring lines are connected, you can detach it. And these are turret mooring system, but in the right side we see that spread mooring system, meaning that all the mooring lines are spread in different location, and the vessel will be fixed in that position. It cannot rotate. But in the turret mooring, the benefit is that the vessel can be moved in one point and it can rotate surrounding that point, but the production will not be hampered. So in my vessel that I used, it will actually use the internal turret, the corner part. And here is the types of mooring system that we have already available. One is tout mooring. It's a kind of the synthetic fiber ropes. We can use that. They're pretty much stiff. And we also have the catenary mooring system, where the mooring system is actually comprising of chain, steel rope, and also a chain. That means that in the seabed you will put chain and then some steel rope, and in the upper side you will still have the chain. And another types of catenary mooring is use of buoy in the total chain to give some extra buoyancy there. And in the figure below, you can see that the mooring line starts from the anchor, and then you have the chain, and there is a connecting link, and then the steel wire rope. And if you have buoy on the mooring line, then you can attach it, and later we will have chain again. So what we are trying to do is that we want to do the fatigue analysis of this chain. You can see that because it will experience a lot of cyclic load. and that's the problem for it. So it will experience the fatigue damage throughout its lifetime. So we need to analyze it, but we'll try to do it in a simplified way. Let's now give us some idea about the state of the art method, meaning what methods are already available. So what we can use is that we can do the analysis in two types of system. One is frequency domain and another is time domain. So the first approach is a simple summation approach, and second one is combined spectrum, and the last one is dual narrowband. And all these three systems are frequency domain. And that means they will not require that much time. That's okay. But the later two method, the Weber approach and the rainfall counting method, is time domain analysis. That means you need to calculate the time series, and you need to calculate the fatigue levels of the time series for every cycle. So, so if, like for example, here you can see that in that rainflow counting method, this method can count the cycle, all the cycle that's involved with the wave loading or other types of loading for the vessel, and it will count all the cycle. And for each cycle, you need to calculate the damage, and then you will finally get the damage. So you can imagine like how much wave a vessel can experience. Every day the vessel experiences lots of wave. So you need to calculate all of them to get the accurate result. And it's not for only one day, it's like for 5 years, 10 years period. So there will be a lot of cycle that will experience by the structure. So that it requires a lot of time to simulate that type of analysis. So what we are going to do, we are trying to propose a simplified method. So that will also give a similar result like this one, but it will not be that much lengthy process. Okay, so here is the method I tried to propose. It's actually a modified version of the Weber approach. In the Weber equation for fatigue damage, we see this equation. Using this equation, we can calculate the fatigue damage of any components. That is that here we have this D is meaning the fatigue damage, and here the number of cycle the structure will experience, and this AD and this M is basically get from this SN fatigue curve. This is a parameter for calculating the fatigue damage of, for example, a chain or a wire rope or a spiral wire rope. And another thing is this maximum stress. This is like when a vessel moves and the chain is attached to the vessel, and when the vessel moves there, it gives tension in that chain, and this tension eventually gives a stress in those chain. So we need to know the stress from the tension. And the last one is this Weber parameter. That's we are basically interested of. Why? Because this Weber parameter varies from 0.5 to 1.5. We don't know which one is correct. That's we're going to find out. So if we can know that what Weber parameter is correct for our, like for example, a peso, then we can simply use this equation to know the fatigue damage. But this part we need to be sure that which parameter we can use. So in our this paper we will try to simulate a model and get the fatigue analysis of that model, and then finally we can relate this fatigue damage to get the proper H value. That's what we have done here in the paper. Okay, let's talk about something more here. Okay, here. If we can find the sigma, this stress value, and also the number of cycle stress for the ULS condition. Let me just clarify you what the ULS condition means. This is the ultimate limit state, meaning that every structure like a peso, modules, and whatever it is, it must be designed according to this ULS condition. So even though if you don't want to do the fatigue analysis, you must do the ULS condition, design condition. You must need to fulfill that. So in my approach, I will try to take those results, what you already have, to calculate this damage. So it will significantly reduce the time required because I already have the answers. I don't need to calculate those conditions because every vessel will be designed according to this rules. So that's one thing that will be contributed to us for reducing the time. Okay, so now let's come to the point how we will calculate the stress here. So in order to find the correct wearable parameter, first the value of this stress and the number of cycle we need to assume that, and how we will assume it, we'll get this stress from the tension process of the mooring line. It's like if system experience like wave load shear, something like that, it will also experience this tension, and the tension will be the same as similar to the pattern of the wave load. And we know that the wave, it has like two parts. One is the low frequency part, that's we can see here this curve is the low frequency part, and also a high frequency part. So for our case, we will take the tension that is the most probable largest maximum, meaning if we do some probability analysis, we will get this value, and it actually already it should be calculated as from the ULS design condition. So we don't need to calculate this one. So it will reduce our time too. So we can just simply take this value from the ULS design and also this one. I'm just showing here that how the process will be done, but we will get this value from another calculation. And later we will need to calculate the number of stress cycle. So why we are doing this? Because in the previous equation, if you see that we need to know this stress and also the number of cycle. So that's why if we use this equation and use the method here, and we can know this stress and also the number of cycle using the data, this one and this one from the ULS design condition. So let's talk about the model. To get what I have, for the model, I actually have to do it in two different analysis. For the frequency domain, I have used the Mimosa software, and also for the time domain analysis, I use the similar model. So here you can see the vessel, and all the mooring lines here are attached to this turret, and the turret position is like 100 meters from the bow. So here is the particulars for this vessel. Its name is Osgard Alpha. It's actually operated near the Norway region. So in order as we are using two different models here, we need to verify both of them acting correctly. And as a proof of this, we have calculated the mooring system restraining force, how they are acting in two different models. And as you can see that they are pretty much almost the same in their behavior. So now the properties of my mooring lines, meaning that how the mooring lines are connected in each point. Let's see, this is the anchor, and then the chain is connected here, and then the wire rope, and again chain. Okay, these forces we have applied, the wind, wave, and current forces. And finally, these results we have got from our calculation. And as you can see, this is the maximum tension and the mean tension and the sigma and n naught. Knowing this value, we can just simply do the using that previous level equation, we can get this H parameter, what we try to look for. And as you can see that this line represents the value of H. And now we know this value. From our research, now we have find the H value that we are intended to look for. And knowing this value, it's now easy for us to calculate the fatigue damage. Here I have simplified it, like this M and H, this M value we know from the SN curve, from DNV. This A value we also know from the SN curve, and this sigma and this number of cycle we know from the ULS design condition. The only thing we need to know is this age, and that we have already got from our research work. So you can see that all these result items you already know, and all of these things are unknown, and we have get from this. And now all you need to do to get the fatigue life is to solve this equation, and we will simply get the fatigue life of the main system. So it will reduce the time. But there is some recommendation for further work that it was done only for 320 meter water depth, but nowadays the marine system is going further, so we need to calculate that also. And also it is done only for FPSO. We can do it for semi-submersible and modules. Thank you.
This paper is now open for discussion. Any question from the audience? Yeah, please.
My name is Tawfiq Islam. I am a graduate from this department. I have completed my graduation in 2007. My question is, all we need to get the viable parameter maybe is, so how you account for the variability of H parameter? Have you ever compared this parameter with any experimental data?
Yes, I have done this simulation here, and also this result is like this 0.5 to 1.5 is already valid. I mean, it should be within this range. So if it doesn't fall within this range, it's not valid. But in my case, I have shown that the data I have found is within this range. So you can take it as valid data.
Yeah, please.
From your mooring line, you got a catenary mooring line.
Yes, yes.
How did you select that? What is the dimension of that mooring chain?
Yes.
Is it a chain, full chain only?
No, it's not a full chain. Starting from the anchor, there will be a chain that have a lesser diameter, because it will be lie down on the seabed, and then this chain will be a higher, because it will interact here. It will go up and also down.
How do you make that touchdown point?
Here?
From zero, where is the anchor, and is it a conventional anchor?
This anchor is like it. We have taken this just for a fixed point, not calculating that much.
But where will be the touchdown point? From this curve, can you get the restoring force?
Restoring force?
Restoring force by the mooring line. From this curve, is it possible to get?
Restoring force? No, that's not from here. From here, this curve we will get the restoring force.
Restoring force.
Yes.
Any other question?
Okay, my question is, in general, we have actually one is catenary mooring system, and one is top line mooring system, and one is double. I think there is some buoyancy
element. Yes.
So which one have you used, and do you have any general ending, like which is better for fatigue design?
Yes, nice question. So yeah, we're talking about these three. So though I haven't done research with that one, which one is better here, but as you know, that chain is like more prone to this fatigue life. Not the steel wire rope, they are not that much. So if you can use lesser chain and this much wire rope, it will be better for your design of the main line. Also, it will give you lighter weight.
I just like to ask you one question.
Yes.
Is your method, proposed method, also valid for completely reverse load? I mean, your element is flexible. It can only take tensile load.
Tensile, yes.
For non-flexible load, we can apply both tensile and compressive load.
Yes.
So it's in completely reverse load. Once I will apply tensile load and compressive. So for this type of loading, is your method valid?
It's basically for mainland we only account for the tension load.
One direction.
Only for one direction, yes, because the vessel, the mainland only gets the tension. It doesn't get any compression there.
Okay, let's give you a big hand. Now I welcome the presenter of third paper, Model Analysis of Crack Cantilever Beam by Finite Element Simulation. I see there are several authors. I'm not sure who is the person. Author is Mr. Suman Mia. Mr. Suman Mia, please.
Assalamu alaikum. I am Mohammad Suman Mia, welcoming you all to this presentation. My paper title is Modal Analysis of Cracked Cantilever Beam by Finite Element Simulation. Several researches have been performed in this topic, and these researches covered the natural frequency of cracked beam for different crack location, crack depth, and different mode shape, and they have compared their result with the uncracked beam. But those researches do not cover the size of crack opening and the effect of meshing. So I have taken this topic to clarify my view and to contribute in this field, that how the frequency varies to the size of crack opening or the effect of mesh quality, including all this that have been done already. So my objective is to determine the natural frequency of both uncracked and cracked beam for different size of crack opening, crack location, and crack depth, and also for the effect of mesh quality for different mode shape and the comparison of result with uncracked beam. So the importance of this study focuses on the things of resonance. We know that when the applied load frequency matches with the natural frequency, the structure may vibrate with higher amplitude, which may cause failure. So it depends on mode shape, and I have taken this study that if the crack present, then how the frequency varies. It reduces when the crack present in the structure, that is uncracked beam and cracked beam frequency is not same. When the crack is present, the frequency reduces. But what is the pattern? Where if the crack is present in the middle or the side, then how is the pattern of the variation? So I try to understand what will be the pattern. Now these things are about natural frequency definition or resonance. So I think it should be skipped. Here is the theoretical natural frequency calculation. From Euler beam theory, we can calculate the natural frequency of cantilever beam. Here the parameter, the length of the beam, the modulus of elasticity, the area moment of inertia, and the mass density, and the constant lambda square. This depends on the mode shape. The mode 1, mode 2, and mode 3 gives different values of lambda square. So if we can calculate the theoretical value and we can compare it with simulation result. So I have taken a model of a beam, material is steel and the length, breadth, width is shown here. And the boundary condition is cantilever beam, so one edge is fixed and one is free, no external loading. And this is the theoretical calculation for frequency. And I have calculated that the mode 1 frequency is 18.576. And now the finite element formulation which is dependent on the eigenvalue solution. So equation of motion of an undamped system can be written in this form, and we can modify this equation, and finally the omega is the natural frequency of the beam, and it is the 1 by root over 1 by lambda. Now I have used abacus as a software to calculate these frequencies. So now the simulation actually depends on what will be the element and what is the size. Now I have primarily selected hexahedral, wedge and tetrahedral element for my simulation. this is all tetrahedral element, Weiss element, and hexahedral element. And these are the results, what we have found, the theoretical result and the simulation result. It shows that the hexahedral element with reduced integration gives a little bit deviated result. But if we use the full Gauss point integration, then the hexahedral element gives the best fitted result for cantilever beam. It is 18.576 for theoretical and 18.622 for Gauss point full integration hexahedral element. So I have taken hexahedral element for meshing the beam. Now the element size. As the global size decreases, that is the element size reduces. You can compare the result that the global size reduces, the frequency goes to closer. That is, the percentage deviation from the theoretical value is about 0.01% when we take the global size 0.025. That is very fine mesh. Now the crack properties and location. I have taken the crack depth for 5 crack depth 0.05 meter, 0.075 to 0.15 meter crack depth. Crack opening is just 2 millimeter, and considering the crack location for different location 0.5 meter to 2.5 meter, that is 0.5 meter variation. Now the effect of meshing on analysis. If the crack is present, then the meshing is quite different because combined meshing is required. All tetrahedral, all Weiss, all hexahedral and combined Weiss and hexahedral element were chosen for the selection of the meshing. Here the all tetrahedral element, all Weiss element, all hexahedral element, and this is combined meshing. That is at the tip of the crack I have used Weiss element, and for reason further from the crack I have used hexahedral element. And the result shows that if we use combined hexahedral and Weiss element, the frequency reduces much. That satisfy or that is compatible with the experimental available result, that the frequency reduces when crack is present. If we use Weiss element, the frequency is increased, which is not compatible with the experimental result. So I have taken hexahedral and Weiss element, that is a combined hexahedral and Weiss element for meshing. This is the close-up view, and hexahedral element used and Weiss element used. These are the Weiss element and these are the hexahedral element. Now the effect of crack opening. The crack opening size is 10 millimeter, 4 millimeter and 2 millimeter. As the crack opening reduces, that is the crack opening size is lesser, the frequency variation is also significant, but the result is, you see there, the result is somewhat similar and varies in the second or third digit, and that's why I think the crack opening size is omitted in those resources. If we take 10 millimeter or 20 millimeter or 15 millimeter, that result will not vary in the first digit, but it will be significant when we take the crack size is very smaller, 1 millimeter or 0.5 millimeter, but our limitation that the 0.5 millimeter crack we can simulate in using the available Abacus software. So I have taken 2 millimeter as the crack opening size. Now the effect of crack depth. As the crack depth increases, the frequency reduces more. It is because of the moment, bending moment, the stress. The stress is higher and the crack depth increases and the frequency reduces. These are the result for crack location for 0.5 millimeter for different crack depth. The similar pattern is found for mode 2 and mode 3. The same type of graph for crack location 1 meter. These are for crack location 1.5 meter, crack located at 2 meter, crack located at 2.5 meter. Now the effect of crack location. If the crack located at the fixed end, near the fixed end, the reduction is maximum. If the crack moves away from the support, the effect is reduced. That is, if the crack is located at the free end, then the reduction of frequency will be less. It is equal, somewhat equal to the uncracked beam. But if the crack is located at the nearer to the support, then the frequency reduces more. Now for mode 2 and mode 3, different pattern is found. It is depend on the pattern of deflection, because the frequency reduces and then increases. The mode 2 and mode 3 shows different pattern, but mode 1 all time shows a single pattern. Same type of simulation for crack depth 0.075 meter, 0.1 meter, 0.125 meter, 0.15 meter. Now all these graphs and results are plotted parametrically. There is frequency ratio omega divided by omega n, that is frequency of cracked beam divided by frequency of uncracked beam. That is, the ratio 1 means frequency is not changing. So we have shown here the 0.83, that is 83% of the length. The crack is located at the free end and the graph is just horizontal, that is all cracked depth, the ratio is 1, that is the frequency is not changing. If the crack is located at the free end, the frequency is not changing. But if the crack is located just near point, just 16% of the length, the frequency ratio reduces, that is 60%, below 60%. For mode 2, different result obtained, that if the crack is located at 0.5, that is at the middle of the beam, then the frequency reduces more. For mode 3, you see that if the crack is located at the middle, the frequency is not changing. So for mode 2, we get, for mode 1, we get that if the crack is located at the free end 0.833, the frequency is not changing. But for mode 3, if the crack is located at 0.5, the frequency is not changing. So it depends on mode shape, in which mode the beam is vibrating. And this is the graph of crack location ratio. You see that if the crack depth increases, this is d by t. D means the depth of the crack and t is the thickness of the beam. So d by t 0.75 means the crack depth is almost 75% of the thickness of the beam and the frequency is reduced about 0.6. That means the frequency is reduced much for the deep crack. If the crack depth is reduced, then the frequency will not change so much. For mode 2, first it reduces, then it increases. For mode 3, we have got an interesting result that for each crack depth, as the crack location ratio varies, at the middle 0.5, at the middle, if the crack is located at middle, all depth of the crack gives crack frequency ratio 1. That is, if the crack is located at the middle and the beam is vibrating mode 3, all of the crack gives the same result. That is, the frequency is not changing. This is the sample representation of the mode 1 vibrating, and this is the sample representation of mode 2, and this is the sample representation of mode 3. These are the findings that natural frequency reduces due to the presence of crack depending on the location and size of the crack. For constant crack location, the natural frequency of cracked beam are inversely proportional to the crack depth, and for constant crack depth, change in natural frequency is less as the crack position moves from the fixed end. And the crack size opening on the natural frequency is significant only when crack opening size is minimum, and the modeling of crack structure require local meshing, as I said earlier, and as the element size reduces, the accuracy increases with the increasing analysis time. And it also depends on mode shape. So possibilities of future work I have done here for only single crack, so it can be extended for multiple crack, and I have taken a perpendicular edge crack, so it can be taken as the angular crack, and it can be verified by a practical model experiment. Thanks for your kind attention.
Okay, thank you, Mr. Shuan. Now, Mr. Paris, for discussion. Please, if you have any questions. Sorry, yeah, please. First you.
So the thing is that you have shown relative results on the relative position of the cracks, if I'm not wrong. The positions and also the crack depth ratio. But and you say that if it is like 1 millimeter, 2 millimeters, or 3 millimeters, that is less minimum. If the crack length is minimum, then the crack opening length is minimum, then the frequency doesn't change much. I mean, it changes in the 30.
Yes.
Right? But is it? I just wanted to know: is it the length of the crack?
No,
Length of the crack opening?
it is the opening.
Length of the crack opening, right?
It is the width. Width of the
They are
crack.
opening at the mouth.
Opening at the
Opening
mouth.
of the mouth. So I just wanted to know that is it directly that it's a limit? It looks like it's a limit that if the crack mouth opening is 10 millimeter or less, then it is not quite affecting. Or is it the crack opening, the ratio of the crack opening mouth with the length of the whole thing, which is affecting?
I have found that the ratio of opening and length ratio is not so significant. The significance is the width, only the width, not related with the length and the opening. It's not related. I think in my research I have found that it's not related to the length and opening ratio. It depends on the opening. And I can include here that in the software there are extended FEM. There is an option that you can just draw a line or plane and it can act as a crack. So you don't need to specify. You don't not need to specify a notch which is opening something above millimeter. You don't need to do that. You just draw a plane and it will act as a crack.
In your study, if the famous well-known formula, Paris formula is relevant to your study? Paris formula, sir, it's vibration. So I have just determined the frequency. Paris formula is relevant to stress when the crack will propagate. But then you can check that, no? Yes, we can extend this study. We can extend. You have done for various crack length. Crack length. You can do that also. You can include. I can extend this model that if I allow the crack opening, if I allow the crack propagation, then what will be the result? This can be extended. This can be included in the study. You should show a clear picture with the crack. Yes. That you have not shown. Last that video is there. Otherwise, you cannot make out what it is. We have can I say we have ignored that the crack is propagating. We have fixed that the crack width, length, depth is fixed for this analysis. But we can consider that the crack is propagating, and this can be another study. They don't propagate, but various length, crack length, that also fine. Different crack length. Yes, different crack length. This has been done. Okay.
Any other question? Can you analyze using your method closed crack? This is surface crack or
surface open surface
or closed crack or buried crack. For buried crack, your proposed method is
I can try.
You need different model.
because I have selected this method and this model because several research result, experimental result is available to me. So I can compare the result with my result, that is the work is validated to me. So that I have selected that. But this meshing method can be used to simulate some other crack.
For mode 3.
Mode 3.
You told there is no difference in frequency or cracked beam and uncracked beam.
If the crack is located at middle.
At the midpoint of the beam length.
Beam length.
So there is no difference in frequency.
No difference in frequency.
So first the physical significance. Actually there is something in the,
physical significance.
There is crack. Yeah, there is no crack.
Yes, these are interesting findings that I have showed the visual representation. Here the mode shape, a node is created, that is mode 3, a node is created just at the middle of the crack beam. So the crack is contracted, a node is created, and it's like
comes in contact.
It contracts and is like the opening is just contracted, so there is no crack present.
It acts as a closed crack.
Closed. It is closed.
Okay. If there is another question, we can close this paper. Okay, let's give you a big hand. Okay, now I welcome the presenter of fourth paper, simulation-based structural analysis of an oil tanker bucket. This paper will be presented by Mr. Sharat Chandra Pal. Please, Mr. Sharat.
Respected teachers and other audiences, good afternoon. I am Sharat Chandra Pal and I am going to present our research work, simulation-based structural analysis of an oil tanker bulkhead. Our research group includes Professor Dr. Mohammad Shahidul Islam, Department of Naval Architecture and Marine Engineering, our University of Engineering Technology, and Mohammad Humayun Kabir and me, Sharat Chandra Pal. Generally, we design ship following the classification society's rule. Obviously, classification society, it provides reliable structure, but in these features, our objectives are to investigate the level of effectiveness of these rules and also to improve the structural feasibility and eliminate possible weakest point from the structure and also to improve the factor of safety of the structure. For this investigation, we have selected a oil tanker bulkhead from an oil tanker. And for its bulkhead, bulkhead is generally a vertical structure or partition that arranges to divide the vessels or ship in several compartments. Function of bulkheads. There are many functions of bulkheads. Generally, bulkhead provides strengthening to the hull and also resists the bending of hull, and it divides the hull or vessel in several compartments and also reduces the sloshing effect of oil tanker. As we have selected an oil tanker, these are the principal particulars of the oil tanker. This oil tanker has launched on 1st July of this year and it is now under operation. So designing the bulkhead. These are the principal particulars of the components of bulkhead, and all these particulars are selected based on GL rules book. Here, the bulkhead has 10 horizontal stiffener. So the dimension of horizontal stiffener, it varies with water height, and here we have shown the maximum dimension of the horizontal stiffeners. These are the scaling calculation that we have calculated from GL rule books. And here we can see the position of the bulkhead. Actually, we have selected this bulkhead from the parallel middle body of the vessel. And this is the 3D model of the bulkhead. Here we can see the dimensions of the horizontal stiffeners that different at different water level. Actually, the bulkhead is symmetric with respect to the central line of the vessel. That's why we have designed just one side of the bulkhead. This is the real picture of the bulkhead that is under construction. Material properties, we have used mild steel as the material to build this bulkhead, and generally the yield stress of mild steel, it varies from 235 to 250 Newton per meter square. So for analysis, we need to define the boundary conditions, and as the bulkhead, it will be welded with the hull, and the upper side of the bulkhead, it will be welded with the deck. So we are considering that all the outer edges of this bulkhead is fixed. So, as we have selected an oil tanker, obviously it will carry crude oil, and this bulkhead, it will experience hydrostatic load. And during operation, a vessel may experience different types of loading. Sometimes it will be fully loaded, sometimes it may be empty, and sometimes it will experience partial loading. For this analysis, we have considered that the vessel is fully loaded. Some other considerations, we are considering that one side of the bulkhead is fully loaded and other side of the bulkhead and the other tank it is empty, because in this case the bulkhead will experience most hydrostatic load. This type of loading, it will happen generally for collision bulkhead and also for engine room bulkhead. So in this bulkhead, the load acting is in one direction. The vessel is to design crude oil, and the density of crude oil varies from 870 to 920 kg per volumeter. But we are considering here water, because if this bulkhead is sustained for water, obviously it will sustain for crude oil. So these are the hydrostatic calculation. As hydrostatic pressure, it will vary with the water depth. So the bulkhead, it will experience most pressure at the bottom and almost zero pressure at the top. This is the picture. This arrow, it indicates the direction of hydrostatic pressure. Now meshing. For finite element analysis, we need to discretize the whole structure. And bulkhead, it's a huge structure. It has many curved edges and sharp edges. So creating mesh in such region is so hard. That's why we have created several regions and used linear quadrilateral four node shell elements for meshing. This figure shows the generated mesh over the bulkhead, and in our first analysis we have created around 70,000 elements. So now analysis. Our objective is to investigate the level of effectiveness that the classification society provides, and also to eliminate the possible weak point from the structure. So from this analysis, we can see the maximum stress, that is 152, and it has occurred in the joining of horizontal stiffener and the bracket. So obviously this structure is reliable because the factor of safety is almost 1.5, but we have tried to increase the factor of safety, because in the other region the factor of safety remains almost around 3. For convergence test, we have analyzed this model several times. We have shown here 3 results, varying the elements and also increasing the number of elements. But all the time, we have noticed that the maximum strain, it occurred on the joining of horizontal stiffener and bracket, and it's almost same, around 150. And the factor of safety is given around 1.5. So this is the results of our first analysis. The factor of safety, it was less than 2, and also the maximum stress, it was occurred always in the joining between horizontal stiffener and bracket. That's why we are trying to improve these points. Here the factor of safety, it was less than 2. That's why our objective is to reduce this stress. Can we reduce this stress, or can you improve the factor of safety for more reliable structure? I'm going to answer this question next. So, as always, this maximum stress point occurring in the joining between horizontal stiffener and bracket, we have tried to modify the bracket design. So, in the left picture, we can see the bracket that we have used before, and in the right picture, we can see the bracket we have modified. So, we have just made a slight change. In the previous bracket, the flange was straight, but in the modified bracket, the flange has a curved edge in the outer side. So we have changed all the bracket with this modified one, and then again analyzed it. So the left picture, we have previously seen it. It shows the previous result that we have found 152 stress, and after modifying the bracket, we get this analysis and found the stress around 87, and the factor of safety, it has increased to 2.69. So just by making a minor change in the bracket design, we can improve this structure. Here we have analyzed this structure just for the joining of horizontal bulk stiffener and bracket, because always the maximum stress is occurred in this region. There are several regions, many regions where the factor of safety is less than 2. So we can use this method for finite element analysis on this part. Now, this chart shows the comparison between the previous model and the modified model. The highlighted columns, it shows the stress that we have found in the previous model, and the columns, it shows the stress that was found after modification, and all time we have found the stresses that is less than the previous analysis, and factor of safety for all times is greater than 2. This curve shows the change of stress with water height. As this structure has 9 horizontal stiffener, so all the horizontal stiffeners joining with bracket on those points, we have shown the stresses. The blue curve, it shows the stresses of joining point of horizontal stiffeners and bracket in previous model, and the red, it is for the modified bracket and modified design. So here you can see that in all connection points, the stress in the modified design is lessened from the previous one. So our target was to, our objectives are to investigate the classification society's rules level of effectiveness. Obviously, classification society's rules provide us reliable design, but by creating a slight change in our structure, we can improve this. And actually, this analysis result is for the development of ship structure in Bangladesh, ship design companies. So, this study describes the use of finite element analysis for ship structure for the investigation of structural adequacy. So, generally, rules book provides a structure with factors greater than 2.5. But in this structure, in this analysis, we have seen that in some points the factor of safety is less than 1.5. So it's happened because due to design inadequacy in some points. So our objective is to increase those points. So from our analysis results, we got a factor of safety, overall factor of safety, that is 2.31, and a new modified bracket. Our ongoing future, actually we are not telling that it's the final design. We just proposed it. It's possible to modifying the design for increase the factor of safety and to get more reliable structure. So our future works, it includes to find the more vertical stiffener to resist the bending moment and bending tendency, and also to find the orientation of other stiffeners. So here we have shown this analysis just for oil tanker, but we can make such kind of analysis for another vessel. So thank you for having this.
Okay, thank you for your presentation. Now it is open for discussion. Please.
I have one question. Why you choose the bulkhead at the middle? Why you didn't choose at the end of the bulkhead position?
Actually, we have choose this bulkhead position because in ship, in the middle position, we get the maximum size. That's why.
And another question is where you pick the stress in the element.
Sorry,
You used quad element, right?
yeah, quadratic element.
At which point you pick the stress? I mean, you sample the stress.
I mean, in the joining of horizontal bulkhead, I'm going to show you. I mean, these are the point. This is the horizontal stiffener.
It's okay. Can you show me the elements, highlight elements with flow nodes?
Do you want to show this?
Element,
Okay,
flow nodes.
good.
In this element, why you sample the stress? You got some values, right? In the
Yeah, just on point, in one point.
1 point in the
I mean, in node.
node.
Yeah,
So nodal average will be big or
nodal average. Yes,
You are mentioning about factor of safety.
factor of safety.
The conventional design we take factor of safety. But in the modern design it is being switched over using partial safety factor.
I mean, local factor of safety.
Partial safety factor. Not a factor of safety. Like LRF is load reduction factor design. In that new approach based on probabilistic data into that. It is something else is considered that is considered better than the working stress concept is your factor of safety.
Yeah, our main concept is to improve the factor of safety.
But then improve the factor of safety is a problem. If you give more factor of safety, you can give a
No.
then the waste of material. To avoid the waste of material and provide safety, you approach the
Yeah, here we hadn't changed the thickness. The thickness is same. We just changed the design and just keeping the thickness and material same, we can improve the factor of safety.
Just changing the shape of the structure.
Just changing the geometry and shape of the structure.
what was the thickness of your stiffeners?
I'm going to show you. Yeah, you can see all the dimensions.
You have only 3 girders or not? You don't have any vertical
No,
vertical girders?
vertical girders. We just use some brackets for vertical girders. Actually, we have used more horizontal girders.
Do you have any optimal factor of safety? Like what was the basis of your factor of safety? Do you have any optimal factor of safety that you want to reach? That I want to achieve factor of safety of 3. Then what is the reason behind that you want to choose factor of safety 3?
Because when we have analyzed this structure, the other region, in that region, the factor of safety is more than 3. But in some regions here, in the connection, the factor of safety is less than 2. But keeping the material same, I mean, it's not increasing my cost. Okay, so make the structure more reliable. I mean, when this structure will in operation, it will experience a load every day, and there will be a cyclic loading. So crack may happen. That's why if we increase the factor of safety, it will help us to work this structure for a long time. I mean, it will increase the structure's life. Obviously.
Does your structure
We can have only one quick question. We are
does the structure constantly according to just GL rule?
Yeah, GL books.
And stiffener also like there doesn't require any vertical stiffener there for the bucket.
Actually, the main construction, it was horizontal, mainly transverse.
Canvas stiffener. But
Yeah.
I think the bucket is very long and there should be some vertical stiffener there.
Vertical stiffeners. That's why we have used some vertical brackets, and we have used more, horizontal stiffener.
Yeah, this bracket, this is according to the GL?
Yeah, according to GL. According to GL.
And then the coding is also from the, according to GL, the coding condition you have used.
Loading condition, actually, it will depend on the vessel. It's a oil tanker, so easily we can calculate the vessel loading. A structure that is bulkhead, obviously it will experience hydrostatic load. So how much hydrostatic load it will experience, we can possible.
Okay, thank you, Mr. Pal.
Thank you.
Our next paper is response of jacket platform under combined earthquakes and wave loadings. Who is the presenter, please? Paper number 169. Response and control of jacket platform under combined earthquake and wave loadings. Is the author present here? And he is not present. Okay, we can go to the next paper. Response, paper number 206. Response of CFT welded aluminum. Get a big number. Okay, paper number 206. Mr. Shikranda, yes. Please, go ahead.
Enlarging this. Good afternoon, everybody. I'm just discussing one of the ballistic load or impact load on aluminum alloys, and there is a welded using a method called cold method transfer. I am Professor Surendran, IIT Madras. My students, masters were Srikanth and others also joined. And now we prefer light metal parts for the structures, for the marine structures above the main deck because of due to various reasons. One is we can reduce the total weight, and also we can reduce the bring down the vertical center of gravity down. So you can see the various structures are shown here, where the superstructure or deck structure, and also because in view of this impact load or some attacks, etc. So we should be very careful. That means whatever the structure we take, it should withstand such impact loads. And we can see that the ship failed because it capsized, or it may break into two pieces, or it may due to impact loads it will pierce and it loses water tightness, etc. So that safety is very important, and application of aluminum plates is discussed in this paper. So when we see the aluminum, you can see the series of aluminum, 1000 series, 2000, or 3xxx, 4xx, etc. And various aluminum the alloys, and shown with copper or manganese or silicon, manganese, etc. is shown that, and its application also. There are non-heat treatable, heat treatable, and those ones are not recommended for welding. And filler wires, some are used as filler wires, and also alloying elements. And again, I am just repeating the same what I that the grades of aluminum, 1000 series or 2000 series, etc. is the typical application is shown in this slide. And also, please see my paper also. Same thing, the other series also here. Aluminum series available in the market, but what we discuss here is some particular series which is weldable and also can be used for marine condition. And here we can see the tungsten inert gas welding or metal inert gas welding, and this is cold metal transfer. This is one of the methods which optimize the temperature or heat requirement, and it is similar to metal inert gas welding. So using that method we prepared one specimen. That's why I am showing this picture here. And it is a CMT is a modified metal inert gas process, welding process. The motions of the wire have been integrated because there is a filler wire is there in the welding process and into overall control of the process. And also you can just see that what is its CMT about. And such a type is useful for aluminium 5086 to 6061 with a particular filler called 4043, and that can be used for a marine purpose. And this is now some of the high-speed photograph we have taken in a CMT process, and also the lower one is high-speed photography for a CMT cycle. And this is typical 5086 and 6061, and middle one is that filler metal, etc. So I have just tried, we have tried with 1.2 millimeter thickness plate and 3 millimeter. Of course we can try for other things also, but time and funding is the only problem. And this is the transverse weld specification by American Welding Society. The specification what we prepared here for some of the tests, and this is for longitudinal weld specification. And this what discussed today will be like today this in a gun or missile is fired. We call it the internal ballistic or external ballistic or terminal ballistic. So I am just concentrating this here, this point here. So when the target hit and when the gun hit the target, that is here the aluminum plate. So that topic I am going to discuss now. So that impact we can classify like an angle of resistance. Based on angle of resistance, it's oblique or normal, and then impact energy, then based on velocity, based on the energy, and impact velocity based on high velocity or low velocity, etc. And here we just if you in this impact load we can classify it as per based on the speeds, etc. 1300 meter per second to 3000 meters, that is ultra ordinary range. So the conducting experiment will be very dangerous here. This one, this very dangerous. Here also, if velocity is 500 to 1300 meter per second, so we call it normal ordinance range, etc. So what we discuss is this one here only. 25 to 500 meter per second, that is subordinate range. That is pneumatic guns and other laboratory apparatus, etc. So, and this is for speed from 0 to 25. So the actual drop test or and we can see all this occurs in various contexts. And this is the failure mode. The failure mode due to impact. Suppose the missile, the gun come and hit the plate, how it fail. This is a fragmentation. The petaling is there, plugging. These are all commonly we can see that. So in between the petaling and plugging, we call something kinking, and these are all mechanism of failures in that film. And this is a literature survey. A lot of others contributed for this particular topic. And objective health objective of this work is to weld, to test the strength of the welded aluminum plate, that is 5086 to 6061, using this particular fillet, and that is done by CMT, and the ballistic test, and also 3D modeling simulation of ballistic test in Abacus software. And this is a standard, the relevant governing equation by Johnson and Cook. So that model we can have the details of this for this particular material for aluminum target like this. And this is the experimental setup we have. So there is a chamber here, and actuator to open the barrel, and that projectile loading here, and this is a long barrel, and the projectile will look like this, and this is the target will be somewhere here, and these are all the target prepared by by CMT methods, etc. So different thickness possible, and these are all the fixed, where the target will be fixed to the test facility. And this is with the high-speed camera when the gun hit the target. So the movement is shown in this particular slide, but it may not be that clear. This is experiment. I'm skipping that because that video may not be possible here. So we have found out for different velocity actually. That is 100 meter per second, 110 meter per second, and 120 meter per second, and with that 5086 and 6061, and when the filler is same actually, and this is for and after the ballistic after the hit, it is we have shown that for 100 meter this much is the damage, or this is this much response, or for 120 meter this much. So that means we can find out the limit, safe limits in this one from this study. And also for when the gun can be fired at various pressures. This is 3 bar, 11 bar, 9 bar, 13 bar, and 5 bar and 7 bar. And this is the the residual velocity and the ballistic velocity. So whatever this is the safe limit, we consider the limiting velocity possible without any much problems. So that is we use a prepared specimen by CMT method, and this is for 3 mm and 1.2. Green is 1.2 and this is 3 mm, and this is the experimental, and also these are all the simulation actually using Abacus and also the experimental, and these are ballistic response overall trend on thickness of the plate. So this is a similar simulation result. And CMT welded aluminum 5086 6061 using 4043 filler wire to improve the strength of the weld significantly. Aluminum plate 1.22 3 mm can be welded using CMT by 1.2 mm 4043 filler with single pass, and the critical velocity of the ballistic is found and safe loads are determined for aluminum. Two types of plates. Aluminum plate respond to different velocity studied, and 1.2 mm thickness plate respond as petaling, and 3 mm as plugging effect, and it can be it is feasible. Aluminum can be subject to load range less than 90 meter per second, and the ballistic limits of 3 mm CMT weld aluminum plates can be subjected to a load range less than 110 meter per second. And it's possible for the shipbuilding also, or boat building etc. And the CMT's technique is promising. And with that, I would like to I was just running fast because the lights were more. Thanks for giving me.
Thank you, Sir Srikanth. I have plus one objection. I am not
Please.
specialist in this field. You just give impact on the oil metal on, I mean filler material.
On filler, it is not like that actually. The two types of alloys are there.
Yeah, two dissimilar metal.
Dissimilar. Dissimilar alloys only. Basically, aluminum alloys only.
Yeah, both are
That
aluminum
way,
alloy,
yeah. We are using a filler.
yeah, the filler. And you give the impact load on the filler material.
Yeah, on the plate.
On the plate.
On the plate. That plate joint.
It is away from.
Plate joint with two pieces are there. That joint.
Yeah.
So that is we are not on that filler material. Can be anywhere. Maybe when you put it is on the center or somewhere near the center.
Okay, if it is away from the heads.
Yeah, and that was the same result today actually.
If it is away from the heads, it is simple aluminum plate.
Yeah, it is same. Result is same actually.
Same means same result.
Same whatever I have shown some three pictures, no? Some three.
Impact load on the plate, it does not depend on the welding or filler material, because this is simply aluminum alloy, so we can obtain the behavior of aluminum alloy only.
This one
So
also.
there is no impact on the welding.
You mean to this point, no?
Yeah. I'm interested.
This point, huh?
Yes, yes.
Because when the target comes, it will go. It is like that. It may go like that, or it may go straight like that. If it is straight, will try like that, or if it is. But on this plate is efficiency we are checking. This is if it is here also, it should be same actually. That mode of failure, whatever this is what I am discussing now. I am just observing this, whether it is damage or not. But this is damage, this is more damage. You have more velocity. So then what I am considering is the gun size, gun velocity, and its target.
Velocity will have some effect.
Yeah.
But what I am talking about is the location of impact. So
Location, it need not be exactly this point. Next experiment may be somewhere here. Next experiment, same I am continuing with 100. It may be somewhere here, because a slight variation can,
Just like.
Yeah, because I may not be a corrective pressure, etc.
Okay, if no other questions, I can close this paper. Okay, thank you.
Thank you. Actually, my students, MS master's work at this one. He couldn't come, then I had to present you.
Okay, thank you. Now, next paper is the effects of coordination mechanism on vendor-buyer system of a supply chain. Presenter is Mr. Farhaduddin. Please go ahead.
Good afternoon. I'm Mohammad Farhaduddin. I would like to present my research work that's entitled The Effect of Coordination Mechanism on Vendor-Buyer System of a Supply Chain. Actually, this topic is not related to actually direct marine ship design or something like that, but we can apply this there also. So, I don't know whether you feel interested or not, but I will try to discuss these things. Actually, first of all, what is supply chain or supply chain management? I want to discuss these things. Supply chain management actually, if we have in a supply chain, we consider many players: supplier, distributor, wholesaler, retailer, consumer, where commodity flow normally from upstream to downstream, and information flow in both directions. Here, I want to show you. Here, I describe a supply chain where we have many players such as manufacturer, supplier, logistic center, distributor, retailer, coordinator center. Actually, main target or main objective of research is to show the coordination center, how the effect of coordination center in supply chain management. the importance of supply chain management is increasing day by day because of for Bangladesh is developing country. In garment sector is also dependent on supply chain, and I think many ship also it can ship from one place, one country to one country, one continent to another continent. It also depends on how the carrying cost from one place to one place. So transportation cost normally 30% of the total expenditure. So if we can reduce this cost, is important. So cost minimization, profit optimization is our main target in supply chain management. So if we can reduce the transportation cost, shipping cost and other costs, then it's better for the whole supply chain. And there are some complexity also in supply chain. Because of the new technology, all the members of the supply chain are not adapt this kind of technology together, or they have different objective. Suppose if also one manufacturer, he has one individual objective. He wants to optimize this kinds of profit this way. Another, suppose distributor, he has another objective. So the objectives are conflicted to each other. That is why it also makes some problem of the supply chain. So this, there are some related words related to this topic. I myself also, before this we use mixing the linear functional programming problem, and we show some benefit of supply chain using this technique. And many other researchers also try to show how we can minimize the cost and optimize the profit using such of models. So here, these kinds of things actually motivated me or other researchers also. You can find it is the scenario of Bangladesh. Sometimes our producers, they produce huge amount of product, but they are not getting actual benefit. They are middle players, as in, I mean wholesaler, distributor, they obtain the maximum profit. The producer or the farmer, and he is not getting actual cost. That is why he sometimes throw his product and he used to feed back at like this. These kinds of problems occur in our country. So if we want to mitigate these kinds of problems, we need to coordinate our supply chain as a whole. This means that I want to show this way. If our farmer who is a manufacturer who produces the product and the consumer, we have to make integrate them together so that the benefit will be shared by all the members of the supply chain equally or depending on the investment. Normal like this. So the main objective is how the supply chain works. If we have two players, suppose vendor and buyer, and if they share information, for example, their production availability, their inventory level, and their suppose rate of production and other sorts of other things, other players, then how they can improve their supply chain. This is our main objective, and whether it's beneficial for the whole supply chain or not. This is our main target. For this reason, I will skip this part actually. For this reason, we have, suppose this is one scenario I try to show you. Suppose we have vendor zones. Here they produce different types of products, and they are buyer zones where they may consume or they can use as a, or they can consume this thing or they can distribute like this. Two players, and they have some information flow, and if we say they are coordinated together, and whether they are equally, whether the cost of the supply chain decrease and whether they increase their profit or not, and whether the supply chain are become efficient or not. This is our main target. So for this reason, we make a linear fractional programming problem where this is the fractional program where numerator and denominator are the two individual functions, objective function, and this is the return and this is the investment of a supply chain. And x is the vector, that is n by one dimension, c is the cost function, and alpha is the constant, and here d also another vectors. And we want to optimize this ratio where numerator is the return and denominator is the total investment of the whole supply chain. So for this reason, actually if we have many players, they have many objectives. So we have to optimize the objective of individual function. And then in this research we try to combine them together. Together we combine, we make an objective, how the profit. And if we have the individual objective, how the profit. Whether they change or not. This is our main target. So for this reason, we use this functional program, and this is the some parameters we assume for the whole supply chain. And consider this parameter, we have this is our model. This is for a vendor model like this, and where this is the sort of objectives we consider. Here is the return, and this is total investment, such as the fixed opening cost, transportation cost, distribution cost, production cost, raw material cost, and inventory cost, sort of things here. And these are some constraints for this model, and according to this constraint, we solve this objective function by using some transformation. This is another model. This is for buyer model. This is for buyer objective, and there are some sort of constraint for buyer. Considering this is the coordinated model for both vendor and buyer together. If they say together or they coordinated, and this is for the combined model and some sort of objectives for them and constraint. Actually, first of all, we make linear functional programming problem. This is the methodology how we solve this problem, and then we transform this linear functional programming problem into two problems. One is called equivalent positive problem, one is equivalent negative problem. We reduce the main problem into two parts, and then we solve this equivalent positive problem, if it is optimal, and then we have to go here. If it is optimal, we test here. If it is inconsistent, then we don't need to solve another one. And on the other hand, if this problem also unbounded or this one unbounded, we don't need to solve the whole problem. And if this problem is optimal, but this problem is inconsistent, then the whole system has a solution. I mean, we don't need to solve this one. If this one is inconsistent, then we solve this problem and it gives us optimal solution. And this is our transformation. Using this transformation, we solve the problem, and we find that if we consider the price of the product, individual three products, we take three products here. You consider price. This is the before coordination. This is the after coordination, and so we show that the price of the products. Product one here we show, and this way we can reduce the product a little bit, even though a little bit, we can reduce the price of the product. And this one shows second, for the second product we also show that it can also reduce the price of the product, and this is for the third product, and this one is that we try to find the profit, how the profit is changing or not. And in this case also we take several sensitivity of the parameters, suppose transportation cost, production cost, inventory cost, and other cost, and how it's changing. So depending on this sensitivity, we also find that after coordination, we can improve the profit. So the profit of the whole supply chain can be improved if the players of the supply chain was coordinated. So and the price of the product also can be reduced. This also shows the profit of the individual, suppose buyer profit, it also can be improved. Several cases. And this one show the profit for the vendor, and this one we can show. So finally we got a conclusion for this. If the players of a supply chain are coordinated, or if they are individual to independent partner or independent players, then they try to optimize their own objective depending on some sort of constraint. So at that case, if they work coordinated or integrated together, their objective will be one, and at the same time we can increase their total profit for individual players and total whole supply chain. On the other hand, we can also decrease the selling price, that is our consumer will be benefited from here. That's all. Thank you very much for listening. So if you have any question, please.
Okay, thank you, Mr. Porter. Yes, for the presentation, please.
Yeah, so Dr. has given very good paper. So you are a bit shaky that in the shipbuilding it is required or not. I tell you, I mean that is the main thing of the shipbuilding. If you visit a shipyard, and I tell you, even in our country, there is a department called supply chain, and there is a director supply chain in the shipyard. Because in the ship, not only in shipping, you are saying that in the shipping, I am saying about the shipbuilding. This time constraint is very important there. 2 years contract, liquidated damage clause is there. If it cannot give the vessel, there are a lot of cancellation of contracts have happened in shipbuilding. Just is for knowing, is it okay? I tell something
Yes, sir.
relevant because he is from the Department of Mathematics, and he would feel satisfied that how much relevant his paper is with shipbuilding. I tell you. It was required during few years back that engine, after you give them the order, 18 months is required for engine manufacturing. So how life was so difficult. I mean, a contract for 2 years, and if engine is required
18 months.
18 months. So this thing happened. And now the point is actually this liquidated damage, that is very important thing, and you are saying that vendor-buyer coordination.
Yes.
And that is the concept on which this Alibaba and these online shoppers, they have come, and they are making a lot of profit.
Profit, yes.
So this is the coordination you are making with the buyer and vendor, and finally there is a benefit, and that benefit will be distributed between buyer, vendor and consumer.
Yes, sir.
So that is very simple, and you have given the very mathematically a model
Yes.
and quantifying that how it happens. So coordination will benefit. That is the essence of the total game.
Yes,
I have understood that the coordination will benefit. So in all cases, coordination will benefit.
Yes.
So mathematically, you have shown that how much it is from case to case basis. Is it like that?
Yes, sir. We show that.
So you have given an answer that coordination will benefit all. Is it like that?
Yes, sir.
So that is a very universal truth, right?
Yes, sir.
Coordination will
Yes,
benefit.
that-
And through the model, you have shown mathematically that how much it will be
It
benefited.
will be benefited.
And it will vary from case to case.
Yes, sir.
So things are very interesting,
Yes,
and
quantified.
very good and very
Thank you,
nice,
sir.
and very
Thank you
much
very much.
relevant with our shipbuilding, I tell you.
Actually, I am from mathematics.
You visit a shipyard, I tell you, and
I-
then you will understand how much is
So
important.
we can apply it from engineering field, applied field, but
Thank you very
some of sort of data availability you have problem. That is why sometimes we
That is a
cannot.
case study.
Yes, sir. Case study we cannot do.
In the case study,
So-
you can get the data and feed in your model.
Yes, sir.
Your model is ready.
Yes.
So
Then I can actually show how the
Exactly.
real situation.
Yeah.
So now we are
you
doing
need
simulation.
You need a co-op
Yeah.
with a shipyard,
Yeah, yeah.
and then this will be in the next time will be getting a very good paper.
Thank you, sir. Thank you.
Thank you.
very much.
Actually, before this discussion, I thought this paper is relevant. Now I learned that this is very.
I am saying that he was very shaky,
Yeah.
very much relevant.
Yeah. Any other question from this audience? Okay, no question. I have to close this paper. Thank you. Actually, we don't have so much time, so still we have 2 papers to be presented. I just want to make sure, actually, if both the presenters are present here. So the presenters are present here. So, yeah. So now, next paper is challenges and opportunities of big data analytics for upcoming regulations and future transformation of the ship industry, of the shipping industry. The presenter is, what's your name please? Mr. Ibn Zaman, please go ahead. Actually, we want to finish this paper in time.
But I request
I may sound first sound after 10 minutes and second sound after 13 minutes.
Yeah, that's fine. But before start, I would like to allow giving some extra few minutes to end.
Yeah. Only 2 minutes. Extra 2 minutes.
Couple of minutes will be fine.
After second sound.
First of all, I would like to thank you, Buet, for inviting me for this presentation. I'm a project manager of the combined research project between the Newcastle University and the Western Limited. So, the project is based on our paper is totally based on how the big data analysis is related to the shipping industry and what is the future challenges and what is relation with the upcoming regulations. This is the shipping industry overview. Around 90% of the global trade has been conducted by the shipping industry. Around 90,000 vessels around the sea at the moment. And if you see that in the EU, control around 40% of the total fleet. So shipping industry is very important key part for our global trade and economy. What is the big data? Start from this big. That means it's massive. You can see the data is all around at the moment. So you're expecting by 2020, the data generation will be accelerated around 4,300%. The big data, it covers the 4V. First, it has a volume. It's a massive amount of the data, like a trillion gigabytes. So different variation is another V, variety. Data coming from the shipping industry in different sensors. Another one is the velocity, how fast. We get the data from very fast right at the moment. In future, we'll get the data from the nanoseconds. Second one, so the final one is the veracity. That means the uncertainty. Can you trust our data? So the trust and truth data is very important. So this is the definition of the big data. Big data comes with different types of challenges. In my left-hand side, you can see the data challenges for the data quality. Quality must be important, consistency, and reliability. So the data reliability is a very crucial part of the industry. If it is not reliable data, it will be misleading. Another one is the data availability and the linking data. We have the data need to be available from all types of sensors, and then we need to link all together those data, like the data interdependency. Because one data is linked with another one. On the right hand side, you can find about the data presentation and scalability that link with the different formation of the data. And the life cycle management. It is very important because every data has some valid time and we need to update every time. This is the additional part which is linked with the shipping industry nowadays. The first key part is cyber security. In the UK, Ministry of Defence has spent lots of £billion to make sure the data is secure and confidential. Another part is the integration and transfer. For shipping, we had a main problem with the data ownership. We had a vessel, but the owner the data is mine. The class society need to know the data first for the validation. Port, they have owner of some data. So ownership is very important for the shipping industries. And the final one is the business model. We are expecting that by next 20 years, the whole shipping industry business model will be changed. Because you have already known the smart ship, unmanned vessels, so those parameters will help us to change the business model in our future. You can see the source of the data for shipping industry, like from the design. We get lots of information and data from design, material performance, condition monitoring, even the meteorological data. And you can also find like some accidents, cargo carried, different communication parameters, and the maintenance work. So all that data is linked with each other. So this is the source for the different data in our shipping industry. In the 4 phases of the analysis, we need to gather the data first, we need to transfer it to the shore or the system, then we need to process it, and then analyze it in the right way. According to the BNBGL, a current modern ship per day generates more than 20 gigabytes of data. It depends on how many sensors, and we are expecting lots of data will be generated in the near future. This is the model. You can see the sensor data, like we have an emission monitoring system, we have a data for the ballast water, main engines, diesel generator by using torque meter and fuel flow meter. All the data coming through 3 different ways. It will be continuous, it might be discrete, or it might be demanded by the operator. It might be some known data from the manual. Then we do the statistical model. Different statistical models have been used, like regression, statistical process control, cluster analysis. We use the fuzzy logic and artificial neural network. So after the acquisition and analysis, when the data is driven model, then it will help us undefined functions. It will help us on fuel and energy, maintenance. It will help us to reduce the emission, safety operation. It will help us in the shore management. It will also help us overall performance monitoring of our vessel. Shipping is a highly regulated industry in the world. So all of the different regulations come day by day. So if we do the process of those data, it will help us to meet the regulations. And I will show you another regulation at the end of my presentation, which is linked with the data analysis. Right. So if you see remember the model, which I'll show you here, acquisition, driver model, and functionality. In our research project, we have developed a system, it's called automatic mode detection system. Right. Every vessel is different. Their operation is different, so their mode will be different. So in there, if you see a dredger, they have a dredging mode. In OSB, they have a dynamic positioning mode. In the cargo vessel, they have a loading and unloading modes. But some modes are common, like port, transit, standby. So if you see here, this is the home port 1, and the port mode, it will be automatically detected when the vessel coming near within 1 nautical mile. Currently, we have found that the mode is pressed manually. So there is a very high risk of human error. And sometimes the charter want that I need a fuel consumption during the transit period because I will pay for that time. So that's why the mode is very important. Operators want to monitor the engines based on the different modes, like which engine running in that mode, why the consumption is high. So that's why it is a very important project, because the mode will be detected without human intervention. So you remember so it is the same data analytic model. This is the sensor data. This is the model. We get the data from the flow meter of the fuel consumption, speed over the ground, all the real-time data coming every minute. So the every minute data, we are expecting around 1,440 samples each day. This is the acquisition. We captured those data. And this is the model we developed, so statistical model. So we will create the mood profile of individual moods. So when the real-time data match on the mood profile, detects the mood automatically. And the data will be, and after that analyze the data, it will send the automatic report every day. So at the beginning, we intentionally create the moods of the Princess Royal. This is a research vessel of Newcastle University. After that, we implement the data analysis in the OSV. So this is a long video. I'll make run for only for 1 minute. So you can see in the OSV, this is a specification here. This has a 2 control bridge propeller. It has a 2 Mach engines. It has a port, standby, transit, DP, and no mode. No mode, we have found that it is a transitional period. That is the mood changing period. So the sample is running at the moment, and this is the distance from the home port, like 130 nautical mile. So you can see that when the speed changes, it's matched with the fuel consumption and the mood profile. Every time it's changed mood. Now we switch the mood from the GP at the moment. So that's when you can see almost the same distance. So it doesn't move. So it's close to the rig at the moment of these OSV. Right. So the vessel is now in dynamic positioning mode. Here. So it's been run for a long time. So if I move forward a little bit, you will see still in there 130 nautical mile. Well, that means they're still in the range of the rig. Now the vessel has got a speed, so they are moving back to the port now. So if you see the speed up from the distance has been reduced, and the speed is almost 12 knots. That means the vessel is in transit mode. But it is automatically detected by the data. So if you come closer, now the vessel is almost near to the 2 knot of close to the home port. There is some reason that I don't know why they make this speed of standby mode at the moment for a few minutes. That's the need to time to analyze. So this is the very important part, that why the vessel was standby in that time. Now the vessel is in transit. Now the transit to the port mode, because it's come to the close to the port. So that's means the mode has automatically detected without human intervention. After end the report, you will get this report for every day. In there you can see this is the 4 engines and auxiliaries. So you can see this is a mode-wise engine uses. So you can see that in transit mode, engine 1 has been used a lot. This is the overall fuel consumption summary. So it will help the operator about the maintenance of the engines, that which engines need to maintain. Because all the data from real time, there's no human intervention. So the major parameters, you can see the ship operational modes, fuel consumption, and we can get information on the vessel activities. It will help in the assist the sailing time. We published 2 papers in Wiener Conference, and one is the IGME journal. It has been awarded for European Marine Research Award in this year. Right. Please allow me 2 minutes just to go for the MRV regulation.
You can take 2 minutes more.
No, I guess I need another 2 minutes, like 4 minutes. Please. Let's say end of the regulation. Okay. So, right. Here it is. Nowadays, the shipping industry is very concerned about the regulation. COP emission. Shipping industry around emits 3% of the global total CO2 emission. It is very minor from other industry like air transportation and road transportation. But if you see, if you don't control it at the moment, the emission range will be more than around 250% by 2050. So that's why, and almost 180 million tons of CO2 has been emitted in European marine transport area in 2010. So that's the reason, this is the motivation to make a new regulation. It will be, it already into the force, but it will be started from next year. So this is called EU MRV. By using this regulation, the European state want to reduce the CO2 emission 2%, as well as they want to save around 1.2 billion by 2030. Because the CO2 emission is linked with the total fuel consumption of the vessel. Right now they don't have any data, but they want to monitor these data by implementing this regulation. Yes, here it is, table in details. So this is the regulation. It is passed in 29th of April 2015. I will show you the timeline next slide. This regulation want to get the data with the vessel which is more than 5,000 gross ton of any vessel, excluding military and fishing, because military is for security. And then it is flag natural, so it will be implemented for any flags in the world. And so they need to monitor with the vessel coming from the EU area to go to outside the EU area. So they need to give the monitoring of the CO2 emission for their activities. I give an example. For instance, a vessel coming from Singapore, come to Chittagong, then go to the EU or Rotterdam. They need to give the total fuel consumption information, how long the time is spent. So it will follow in the next slides. And the same case, if the vessel coming to the Rotterdam, go to the Singapore, they need to also give those informations. This is the EU MRV timeline. We are not here at the moment. So we need to submit a monitoring plan to the verifier. And then, because they will verify the overall vessel CO2 emission monitoring plan, how they calculate the data. Then it will data collected from the 1st of January 2018 to 2019. So this is the one monitoring period, monitor the CO2 emission. All the data will be verified through the verifier every time, and then send it to the EU flag. Similar case happened here. After 2020, we are expecting another new regulation, or they might be more strict. That's why they need to know what was the emission. And they have some really strict fine if they don't have any monitoring plan on the vessel, if the data is not verified in the EU state. This is the overall process. You can see here there's a two loop. Main key part is the ship operator. They need to send that data and monitoring plan to the verifier. The verifier will issue the document of complaints, and then the ship operator needs to send the verified emission report every time to the European Commission for the vessel. And then the European Commission will publish those data. So the ship operator will go to the company. The system administrator is the accreditation body who gives the approval for the verifier. And we are expecting the list of verifier by April next year. And then they send the data to the flags. It will be published through the flag or the commission, EU Commission. This is the overall process.
Time is
over.
I request you to finish as soon as possible.
As soon as possible, that's fine. So this is the data you need. We need a full consumption at sea, full consumption at berth, time spent at sea, distance sailed, cargo on board, transportation work, and any efficiency parameter like EEDI or SIM. Those information and all the emissions need to be calculated for main engines, auxiliary, boiler, all available sources of emissions. This is the 4 methods: marker delivery node, tongue sounding, and flow meter. So all the fuel consumption need to calculate by the carbon emission factor. So I give you some example of why the data is important, what type of challenges we are going to face in the near future, and how you can see why the data is important and the data type of regulations coming towards forward, and then I give you a demonstration of a system which is generated from the data and how the automatic mood detection system can help us to the MRV to meet the regulations. So finally I want to say that the data is very important because it gives information, it will help us to make the decision making, it gives you overall transparency of the operation, and it also gives the real-time advisory. So in the future, we can help the data to transform our industry. So those regulations is not a threat, it's an opportunity for us towards going to the made in IT system. And it will lead us toward the future. Thanks for your time and thanks, Chairman.
Okay, thank you,
Yes, again.
Okay, please. Yeah.
Same man, same person. I'm questioning any. Yeah, it's very, very exciting because especially you are in Newcastle, right?
Yes, I'm coming from England just only for this present, only for today.
It's great. Because I'm excited because I am also a Newcastleian. I'm studying in Newcastle University in the early 80s. So that's why I'm saying that.
Can I ask your name? Sorry for
my name? Yes. I'll be giving you my card. Kabirul Chaudhary. I worked with Protus Sen. Protus Sen, he was the head of the department. P. Sen.
P. Sen, okay.
He died. I think Dr. Buxton also worked with. He is a part-time there. So you are working with some faculty there, right?
Yes. What happened? This is a common, the Innovate project. Yeah. So it is a massive amount of the project to monitor the whole vessel efficiency. So I work with Dr. Kevin and Dr. Rose as they are from the shipping, Department of Mass, Marine Science and Technology, and we are linked with the Institute of Industrial Statistics.
Yeah. So you had been based in Newcastle sometime?
I'm now based in Newcastle.
No, I'm saying university based.
Yes, I'm in both. So I work for a company, also the university.
So that's the concept. University industry relationship. People used to, when I used to do that 20 years back, people say, why is this professor leaving the chalk and duster and they're moving around the industry? But now things are coming true. Anyway, so thank you very much. My points are that this big data, in early 80s, I came across with a paper. The name of the paper was History as a Tool for Ship Design.
Yes.
So, but this was not done by a naval architect. This paper was authored by a historian. He was a director of British Museum, Mr. Gilman. So he said that history can be used as a tool for ship design because there are a lot of accidents that are happening every time. So we are not making it happen, but nature is making it happen. But we can use it in the very right manner. I mean, those accidents starting of Titanic or whatever it is.
Yes.
So one thing I am saying that your data will be also, in addition to whatever benefits you have said, it will also be a great benefit as a feedback to the ship designer, because you haven't mentioned that. Because you have said about the operation, these lots of data of the ship operation, if comes to the original ship designer, they will make a better design on the basis of the data that you will be feeding them, because you have said that these are the data which are there. So there will be new regulation. One thing I'm a bit surprising that when there will be reduction of emission, at the same time reduction of cost. I mean 2% reduction of emission.
Yes.
Because emission and cost is inversely proportional. But here you are showing that there will be 2% reduction of emission.
Yes.
And again there will be 2% or 4%.
Not 4%. They want to say the cost around 1.2 billion.
Percentage wise, I mean
Okay.
1.2 billion means total. But when you have said that 2% reduction, can you go to that slide if possible? If
sure.
this I'm given the chance, you have said that 2%, yes, 2% will lead to net cost reduction of 1.2 billion.
Yeah.
So emission you will be reducing and you will be reducing the cost.
Yes,
by
it is.
this big data, right?
No, because what's happened, first of all, I want to answer this question, because when they see this is the total emission of 3%, this 2% is for the EU states, not for the total of 3%, first of all. Because this is the EU MRV, like this is only for European Union, when the vessel coming to EU state or out to the EU state. Okay, and then it's not a global. So they want to say, because if you want to reduce total CO2 emission of 2%, you need to resave the fuel. First of all. So because of fuel, I will show you, this is the next slides in here. Every time you need to give the emission by consumption, fuel consumption monitoring.
Now I got it. You are saying that this 2% reduction of emission will lead to that
1.2 billion.
But exactly. I was thinking that ship will have some sort of, something hardware which will reduce the emission, but then that hardware will have some cost.
No, I know, because
how automatically this reduction will be there?
No, it's not like there is no hardware required installation,
right?
because
just data exchange.
Data exchange, what happened, they want to monitor the data, and this by 2030 they want to reduce the 2% of total EU emission. So that's why they give, this regulation is not given by IMO, first of all, this is given by European Commission, so this is regional. So they want to say, okay, we are targeting, last year, because in 2010, they emitted around 180 million ton of CO2. So they targeted, okay, if I'm using this EU MRV regulation, by 2030, we want to save 2% of total CO2 emission, which can lead us to save on the fuel and reduce 1.2 billion. And first of all, I want to say, because of the shipbuilding, if you see the data...
I think, sir, you can discuss this session. Some time.
Yes, in here. So you can see the map, the design, everywhere, material performance inventory, so the data is interconnected.
Yes. Okay.
It's like closed loop. So it's not that they send it, but they'll feed it back.
You can still discuss on this paper after this session.
Thank you very much.
Thank you, Mr. John. The last paper, but of course not the least of this session, is short circuit current calculation application for AC 3-phase on marine and mobile offshore installation space for IEC 6136. Please can Mr. Umjan Adi, please.
distinguished chairman and distinguished to our audience, good afternoon and assalamualaikum. Today I would like to deliver my presentations about the short circuit calculation application for AC 3-phase on marine and mobile offshore installation based on EIC 61363 standard. So this is the current factor. This Anjong Adipanji Pradama is me, and Radhika Ardiando and Tren Indrawan. We are from BKA. BKA is Bureau Classification Indonesia, is a national ships classification society, which is engaged in classification and survey of ships and offshore installation, and also in statutory services. The background of our paper is the manual approval of short circuit calculation will take a longer time. And second, the record is not well organized and difficult to trust. And the last one is process human error and misinterpretation risk. The objective is to develop a reliable short circuit calculation software which is intended for ships and offshore installation, where the calculation result is stored in database and integrated to ships register, so can be accessed easily, for example by the ship's name or the IMO number. And also to facilitate the stakeholder increase their design and to reduce the time needed for drawing approval. The methodology of this software development is, the first is literature study. In this step, the first step, we are collecting all necessary information such as from the textbooks, regulation or standards. Then we go into the next step is software developing process. In this second step, we are making the software, the basic formula from the spreadsheet program, and after that we are converted to Visual Basic code, and after that we are making our validation. We make a validate process with the commercial source software. After that, the third step is integration to Dewaruchi. Dewaruchi is BKA software, which consists of ships cancelling calculation, the stability, EED calculator, machinery system, and electrical system. This software is connected to Dewaruchi data center, which is cloud computing. So all information, all of the calculation result will be stored in our cloud server. The short circuit. The short circuit is occurred when the leaf part of equipment or conductor is connected to the other conductor or to the ground. The electrical current will rise very high, about 5 times of nominal current in millisecond. Okay, we'll skip. This is the dangers posed by the short circuit current. This is the curve created from the synchronous generator terminal, which is there are 3 different times. The first is sub-transient, second is transient, and the third is steady states. From this curve, we can see there are 2 components. The first is a sinusoidal component, which is from the AC component, and the second is DC component, which is strike like this and decaying to the time. At the beginning of the circuit, the current will be rise from until 3 or 6 times here, and after the time the current will be decaying until the steady state condition. The formulation of short circuit synchronous generator like this, the AC component, DC component, and the P current. P current is summation of the AC component and DC component. This formulation we will use in our calculation. This is an example for the synchronous generator. This is the scope of our calculation. Is the first is the frequency is 50 Hz or 60 Hz, and having a resistance voltage specified in IEC 60092/201/2, having one or more different voltage level, and compressing generator motor, coils, cable, and converter unit, having the armature point connected to the ship's hull, track and impedance designed to limit the short circuit current flowing the ship's hull, and having the natural point inserted from the ship's hull. Okay, this is an example from source wiring diagram of electrical installation in the ships. In the left side, this is commonly diagram, a running diagram of the electrical installation from the generator until the consumer, the load. And in this software, we make this diagram, simplify this diagram to this diagram. The calculation step is first we identify the input parameters such as voltage, frequency, and etc. Second, we calculate the component of impedance, initial short circuit current, and peak current for sub-transient condition, and transient condition, which is contribute from active component or passive component. After that, we are summation of short circuit current, and the fourth is breaking and making capacity, which is for the selection of the protection device. This is the testing and validating of the software. We use a commercial software for validating. This is an input parameter for generator. We use two generators. Its power is 2,500. The motor here, the power is 2,000. Equivalent motor and transformer. The calculation output is like this. Here is our default software, and this one is commercial software. Shows that the default software is 1% maximum higher than the commercial software. But except for the EQM, the equivalent motor is lower, 48.5% lower than commercial software. This is due to that in the commercial software is not include the passive component effects such as transformer and the cable.
I believe so.
Okay. This is the display of our source software. There are four columns. The first is preview of the system to be calculated, the one diagram, and this one is input parameter, which is we put each input parameter here and the calculating three windows. And the last one is the output of windows. The result of calculation will be shown here. The conclusion. The default software is successfully tested and verified by comparing it to a commercial source program. The result shown that the deviation is at most 1% from commercial software. The impedance of passive components should be taken into account when connected to active components. The impedance of passive component reduces the magnitude of the short circuit current. It should be more feature work to be done to verify whether there is a significant effect in the difference of this result when the impedance of passive components such transformer and cable connected to the active component is increased. And the coding process of the float software is about 18% to finish right now. Okay, thank you.
Angjuan. I have questions from the audience. Any question from this? If there is no question, I want to close this paper. Thank you again, Mr. Angjuan. Okay, last Ms. Angjuan Adi Panji. Yes. I hand over this certificate of participation from this. And I hereby declare the closing of this session. Thank you all very much.
Yes, thank you. Well done.
Thank you very much.
Next morning I was
আপনি কি চশমা পরেন নাকি না করেছে এরকম একটা দোকান তো চশমা চশমা পরেও মানে একটা সাউন্ড আপনার